Hello again, welcome to another video. Today we are going to be talking about Kramer's rule and how to use Kramer's rule to solve a system of equations. We're going to look at a 2x2 system of equations and a 3x3 system of equations. Now, for starters, I'm not going to talk about the reason why Kramer's rule works or the proof behind Kramer's rule. We're just going to use this rule and see a couple examples of how to solve a system of equations using this rule. So let's say, for example, we have a pretty simple 2x2 system of equations. We have something like x plus y equals 4 and 2x minus y equals 5. Now you could use old methods that you know, like substitution or elimination, to be able to solve this system, but Kramer's rule uses determinants. So you can go back and check out one of my older videos about determinants and finding determinants either by hand or using your calculator. And we're going to be looking today at 2x2 systems of equations and 3x3 systems of equations. And so Kramer's rule looks like this. It says if you have a system of equations like this, you can find the value of x that's going to solve the system and the value of y that's going to solve the system by finding something called d with a subscript x here over d, and you can find a y by doing dy over d. Now d on the bottom here is going to be the determinant of our normal 2x2 system that we'll take a look at, our 2x2 matrix that comes from the left side of the equations over here. dx and dy, I'll talk about what those are in a minute. And so the value of d, we're going to find a value as a determinant. It looks like being able to take the matrix 1, 1, 2, negative 1, that's the left side before the equations, and take the determinant of that 2x2 matrix. This is something you can do by hand really easily. Just take the diagonals 1 times negative 1 and subtract 1 times 2. And you get something like negative 1 minus 2 to get a negative 3. Okay, so d, your value of d looks like negative 3. And so if we can find dx and dy, then we can find the values of x and y that are going to satisfy this system of equations. dx, I haven't told you what these are yet, but dx says, okay, instead of looking at the 2x2 matrix that's on the left side, let's take the x column, okay, and instead of looking at a 1 and a 2 being in that x column, let's replace the 1 and the 2 on the left with the 4 and the 5 that show up on the other side. So we have a 4 here, we have a 5 here, and then the y column is going to stay the same as it was up here above. So we have a 1 and a negative 1. And so now find a new determinant. Notice it's a new 2x2 matrix, and we can find the determinant of that matrix pretty easily again. That's 4 times negative 1 minus 1 times 5. You get negative 4 minus 5. That's negative 9. So there's your dx value. Okay. Now we can find dy in pretty much the same way. The only difference now is that instead of replacing the x column over here, the 1 and the 2, with the 4 and the 5, now we're going to replace the 1 and the negative 1 that were originally in the y column with the 4 and the 5. So really the subscript here is going to tell you which column you're replacing with the numbers that show up on the other side of the equation. So now the x column is going to stay the same as it was originally up in this d, and you're going to have a 1, 2 here on the left, but now we're going to replace the y column, the 1 and the negative 1, with the 4 and the 5. So it's going to be a 4 here and a 5 there. And so now we're going to find a new determinant of a new 2x2 matrix. Again, not hard. 1 times 5 minus 4 times 2. You get something like 5 minus 8. Okay, and so you get a negative 3. So using these equations up here that we have says that x is equal to dx over d. Just go ahead and copy dx as negative 9. D was negative 3, so what that's going to mean is that dx over d should be a positive 3. That's your x coordinate that's going to solve the system. The y coordinate should be dy, which is negative 3, divided by d, which is negative 3. That means that the y value that should solve the system with this x value, this xy pair up here, are 3 for your x, 1 for your y. If you plug in 3 for your x here, 1 for your y here, hey, 3 plus 1 gives you 4. If you plug in 3 and 1 over here, you get 2 times 3 is 6, minus 1, you get 5. All right, now that we've solved a 2x2 system of equations using Kramer's rule, we are going to solve a 3x3 system. And the only difference here is obviously that we throw in a third variable. And so we're going to start out with a system that looks like this. Let's say x plus 2y minus z equals 2. 2x plus 2y plus 2z equals 12, and x minus y plus 2z equals 5. You probably know that the more variables you have, the more equations you need in order to solve them. And when you start trying to solve a 3x3 system of equations by hand, things can get pretty messy, and it can take a lot more work than to try to solve a 2x2 system of equations. The nice thing about Kramer's rule is that Kramer's rule uses determinants, and we can use our calculator to find determinants of a 3x3 system pretty much just as fast as we can find the determinant of a 2x2 system. So again, what we need is values like d and d subscript x and d subscript y and d subscript z. And so here with this matrix, with this system of equations, what we're going to find, again, Kramer's rule says that the x value of the coordinate that's going to solve this system is supposed to be dx over d. The y value is going to be dy over d, and in this case, this third variable, we have z is equal to dz over d. And we deal with this problem in pretty much exactly the same way as we did with the 2x2 system. We're going to say that the 3x3 matrix that we have, which is just going to represent d, is using the columns for x and for y and for z. We're going to have an x column, we're going to have a y column, and we're going to have a y column, and we're going to have a z column. And so in our matrix, it's going to look like 1, 2, negative 1, 2, 2, 2, and 1, negative 1, 2. And then we're going to augment this with 2, 12, and 5 on the other side, just like we did in the 2x2 case. And so our matrix D or our value of D that we're going to have in our calculations over here is going to be the determinant of the 3x3 matrix that comes from the x, y, z columns. And so it looks like the determinant of 1, 2, negative 1, 2, 2, 2, 1, negative 1, and 2. And so you can do this, you can still do this by hand, and again, take a look at my other previous videos about determinants, but you can also do this in your calculator. If you go ahead and find this determinant, what you're going to find is that d here should be 6. And now what we need is dx, dy, and dz. So I'm going to slide this page over just a little bit. So dx is going to come from, again, just like last time, we're gonna take the, basically it's gonna be almost the same determinant as we have down here. It's just we're going to replace the x column now with the numbers 2, 12, and 5. So it's gonna look like 2, 12, 5, and then the y and z column are gonna stay the same as they were originally. You get 2, 2, negative 1, you get negative 1, 2, and 2. And again, you can find this, this determinant right here of this 3x3 equation, or this 3x3 matrix right here. And what you're going to find if you find dx is that you're going to get a value of 6. Again, you can do that in your calculator though. For d subscript y, it's going to look like the determinant of, well, the original matrix, but then just take the 2, 12, and 5 and substitute that in for the y column for the 2, 2, and negative 1. So d subscript y is going to look like a 1, a 2, a 1, because x stays the same, a negative 1, a 2, and a 2 in the z column. And then in the y column now, instead of the 2, 2, negative 1 that you have over here, you're going to have the 2, 12, 5. So 2, 12, 5. Again, go ahead and plug this in your calculator as a determinant, and what you're going to find there is that you get a determinant value of 12. And then lastly, we need d subscript z, and to do that, we're going to replace the original z column right here with 2, 12, 5. So we're going to have a matrix that looks like 1, 2, 1, 2, 2, negative 1, and 2, 12, 5. Go ahead and plug in that determinant into your calculator. You're going to get d subscript z, it looks like 18. And so Kramer's rule says, hey, if you know dx and dy and dz, then just take dx over d, dy over d, and dz over d. This is going to give you 6 over 6, so 1. This is going to give you 12 over 6, so 2, and 18 over 6, so 3. And so the solution that you get to this system of equations to solve all three equations looks like x is equal to 1, x is equal to 1, y is equal to 2, z is equal to 3. If you plug in all three of those values, x, y, z, as 1, 2, 3, you're going to satisfy all three of these equations. Okay, but this is a lot less work than trying to solve a 3x3 equation by hand, and it's kind of a neat way to use determinants in solving a system of equations as well. Okay, thanks for watching. Hope you learned a lot about Kramer's rule.